Welcome. I'm going to actually start another series because you know how I love to have 100 series going. This one's going to be dealing with some Python script, and it's going to come out of the Essential Mathematics for Computational Design, the 4th edition by Raya Isa and Robert McNeil and Associates put it together. Pretty simple. I'm going to be tucking all of these little tiny scripts into, if I group them, basically into my snippet tool. So I can go into here, I can go into Python scripts, and I can grab my curve closest points and pull it out, and boom, have exactly what I need. And the first one's going to be a surface closest points, and you're going to learn how to do that. So basically, I'm going to bring in some points. Here they are, and I'll put them here. I've just generated them, and I've internalized them into my NURBS curve. I'll bring up my bifocal tool, even though I'm not sure why that one wasn't working. And that one needs to be activated, I guess. Enable. There we go. So I'm going to go to my NURBS curve and generate that. I'm going to throw it into an extrusion, and I have the ability to extrude that surface. No problem. I actually am going to generate a point, which is here, that I can play with and move. And you could always put in your surface closest point, which is nice and simple, and that's going to generate from that surface to that point. You get a nice visualization of that vector, and I've got it going in reverse direction right now. I'm not sure why. I could just switch out the anchor, make the anchor from this point, and that should put it. Still, it's going in the backward. You'll see which direction that one's actually going, is surface closest point. And now I'm going to write it into another script here and bring it right into the Python script. And they walk you right through that. Very, very simple. So I still have a amplitude that I put on visualizing that vector going from there to that point. So there's the point. And as I move that, that vector is going to move around, no problem. And I could leave it on visualization as I move that point. So let's slide it over here, and you'll see how it follows the surface. Really nicely follows the surface closest point. The Python script's pretty easy. You go on into it. Here it is. It'll open right up. My kids are making some good noise, obviously, because they love to do that to me. But what I'm going to do is just generate. They give a nice example in the Essential Mathematics, which you can download for free. They give great examples of all of these scripts going through C+ and Rhino script. And here's all you'd have to do. It starts out, it'll give you everything all the way up to the import Rhino script is RS. You'll have to find the closest point. All you have to do is type in this script and start to wrap your head around that U and V are Rhino script surface closest points from surface to point. And one thing to remember when you're doing that, you're going to have to go in here and change the names of your script to point and to surface. And I outputted A and I outputted a normal because I wanted to be able to see that. So it's a little different script than what they did. Instead of just getting the number, I actually wanted to get the normal so I could put it through that amplitude and visualize that vector. So that said, you're going to use your U, comma, V equals Rhino script, surface closest point, and that will come up as you start to type it, which is pretty awesome. So if you type in Rhino script like that and then surface, you're going to see you can tab over and grab those tools. It's a really nice, simple thing, and I'm going to write these scripts and use them as snippets whenever I need them from now on, and I'm going to get away from having to do all this node-based stuff. So big change in my life. I'm going to try and get that happening for efficiency. And next, you're going to get the closest point. Closest point, just gave it a variable name, rs.evaluate surface at surface UV, which you've already built as variables. Then you're going to take your direction is going to be rs.point coordinates at point minus the closest point, because that's basically how you can get the direction from that. This is simple vector analysis, which is what the Essential Mathematics Chapter 1 is all about, before moving on to matrices. So this is going to get real complex as I keep moving with it. But I'm happy that I've been able to move from Rhino to Grasshopper to Python. And I have to say that Houdini was an interesting program that got me think coding how important that would be through its vex and script vexing. But then you're going to calculate the surface normal, which is give it a variable normal equals rs at surface normal, surface, and then you'll have to put this in as, I believe, a list that comes out of with the square parentheses of UV. And then you can just have A be the output instead of the output. You can have A come out as direction, and that'll be a dot product of direction times the normal, which will give you that. If you know anything about dot product, it'll take two planar vectors that are orthogonal and then shoot you off a tangent vector, not tangent, normal vector off of that. So that's a simple script. Once you're done, you can run it. It should work. And then you can take it, and you've saved yourself all the time of ever having to do all this other stuff, which is basically bringing in 3 nodes, but it's tucked there every time you need it. And I don't know, it's quicker for you. I definitely want to move in this direction. I like the fact that I can start thinking in Python, and it gets me farther and farther into it. So pretty excited about that. And we'll just grab all the interesting things that are here. There's the original curve and the points that are on, and the extrusion, and there you go. So I hope that becomes somewhat helpful. I'm going to do that, and we're going to keep rolling. And I think the next thing I'm going to get into is exploded box and see where that takes me. Just as a little precursor, I think that's going to lead to some script that will, hard to say what it's going to do, but it's going to use the Grasshopper script in C++ and then in Python. And I'm going to actually deal with, exploding those boxes. So it's going to be exciting to do. Thanks very much for